All right, what if we want to find volume, but it involves two functions, the area between two functions? Well, if we rotated uh, this area, which is between this function and this function, around this x-axis, we would get kind of this 3D shape that looks like this. But if we sliced it and took a cross section of that, it would look like this. And um, what it looks like is kind of like a washer that you put on before you put a bolt in. So this is called the washer method. Well, how would we find the area of that washer? We just want this area. We don't want the area of that circle in the middle. So what we would do is take the area of the larger circle, and then we would subtract or minus the area of the small circle. So that would give us the area, the difference would give us the area of that. Well, we're going to take that same concept then when we try to take the volume of this. So if we now are thinking volume, area of both of those subtracted would be a pi r squared minus another pi r squared. Since both of these have a pi, if you want, you can pull that pi out, and then it would just become the difference of those radiuses squared. And our radiuses are different functions here, one being the function further away, one being the function closer, and you would get the volume. So if you have more than one function, you got to do pi r squared minus pi r squared, or if you factor the pi out, pi minus the function squared. Let's look at an example. Find the volume of the solid created by revolving the area of the region between the functions around the x-axis. So first thing, let's graph that out. So on your calculator, why don't you pause the video, try graphing, just practice it and see if what your graph looks like. All right, let's take a look. You should have gotten a graph that looked something like that. You might see more of it on your calculator. But the part where we have these functions intersecting are looks like between 0 and 1 here. And we are trying to take this area now, and we're going to rotate it around the x-axis to find the volume of that. So in order to do that, we're going to set up a volume function, or volume integral. It's from 0 to 1. And then since it involves two of these, we got to do pi r squared minus pi r squared, or pi, and if you factor the pi out, it'd be the radius squared minus radius squared. So what are our two radiuses? Well, we want to make sure we take the one further away first. So the one furthest away from the rotation line, the x-axis, would be square root of x. And it's pi r squared minus the one closer to the x-axis, that's this one. So that function squared. Now it's just going through and solving this out and seeing what that volume is. One thing when doing that, make sure, especially if you use your calculator here, you probably don't want to put pi in there while you're doing it, because pi, it's that constant, but it's going to throw your answer, especially if it comes out to be like a fraction or a whole number. You're not going to be able to tell with pi being multiplied to that. So if I'm entering this one in to do it here, I'm going from 0 to 1 here, not putting the pi in. Since I have those functions squared, I'm going to put them in parentheses here, square root x. And really, we could simplify that since we know square root of x squared here is actually just x, but I'll just go with it here. And minus x squared, we know it's going to be x squared. And then type in our variables integration here, hit enter, and it should give us approximation. Remember, you can figure out what that is as a fraction, would be 1/6. The thing you can't do here, though, then is say answer is 1/6. No, it's not 1/6, because remember, we have this constant pi here, so we want to make sure we include that. So put pi back in the answer. It'd be pi over 6 units cubed would be the volume. So just make sure, um, even though you're not putting in the calculator, that you include it with there. So you would get some kind of volume rotating around that would look like this, kind of a bowl shape with kind of these concave inside, it kind of be concave inside that bowl, and that's what our volume would end up looking like for that one.